So what we're going to do is cover multiplication of polynomials. Okay, which is probably a review of what you've done in Algebra 1, but we're going to also investigate some special cases and show you that it's important that you recognize certain patterns, because if you recognize those patterns, these problems will be much easier. If you don't, you can still do the problem, but you have to put in many, many, many more steps. And so that's the whole idea behind this, uh, trying to cut down on your steps. Now, polynomials come in different shapes and forms. We got the monomial, which is one term. It could be just a constant. It could be something a little fancier. We could even put a z here if we wanted to with a power. Or it could be something basic like x squared, just as long as it has one term. A binomial is an expression that has two terms. We call these expressions because they don't have an equal sign. So it could be x plus 7, x squared plus 7, could be something like 3x plus 2, could be x squared y z plus q, it could be all kinds of weird stuff. As long as there's two terms, one term, another term, separated by either addition, or we could separate it by subtraction. Trinomial, three terms, 1, 2, 3, 1, 2, 3. If it gets beyond trinomial, we just usually call it, I guess you could call it a quadnomial or something like that. But, um, you know, we usually just call it a trinomial. I remember one time we were doing this in class, like it was an intro to algebra. They were just learning these. And I said, okay, what's this? And the kids would say trinomial. What's this one? Binomial. And then we came to this, and one of the students says uninomial, like a unicycle, uninomial. I thought, well, that was pretty clever, instead of a monomial. Mono means one, but uni means one too. So I thought that was a pretty clever idea. Anyhow, moving right along. Let's do a monomial times a monomial, just a basic 10x squared. This is an example out of the book, times 8x to the fifth. Pretty easy, but the main thing you have to remember, we can multiply the whole numbers, obviously, 80. What do we do with the exponents? Do we multiply those exponents? Would that be x to the 10? Because, sometimes we have x times x. Why is that x squared? Well, because we have two of them. So what we have here is we have 2 here and we have 5 here. So altogether we have 7 x's, x to the 7. See, we're not multiplying these powers, we're adding them, because if we multiply them, it would be x to the 1. So remember, when you're multiplying numbers, yeah, you multiply them, but when you're multiplying variables, we add the exponents. So 2 and 5 make 7. If the variable is inside the parentheses, okay? We'll make sure it's inside the parentheses. So one more, a little bit more complicated. You could kind of think this answer to yourself. I guess this was a 3, y2. So if you were thinking this together, and this is a 3, obviously you would think that this is negative 40. What's your sign here? What about the 4 and the 3? We don't want to put, like I did here, put a bunch of x's. What if this was a 40? You'd be putting x's for the rest of your life. So this would be x to the 7, huh? We're just going to add those together. And 7 and 2 makes 9. See? So in math, we try to figure out ways to make the problem faster and easier. We could write this as y, 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 put them all together, y, 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 y. But, it'd be a heck of a lot of work. So we're trying to figure out ways to streamline the problem. And that's what we're going to do in some of these special cases coming up. So it'll be kind of fun. So you can kind of see, not too hard. What if we had, let me put one more down here. What if we had a monomial times a binomial, like they have in the book? Well, that would be pretty easy, huh? We just distribute that like we solve equations. The only difference is usually when we're solving equations up to this time, we didn't get x squares. 1 and 1 makes 2. Then we're going to distribute this again, this 2x to the 5. So that's a negative 10x. See? So not too hard. Just multiplying the 2x times each term. Here the 2 times 3 is 6. The x times x, we added the powers. Here, the 2 times the negative 5 is 10. And then this x just kind of like, falls right through there. So hopefully it lands on something soft and doesn't get hurt. Okay, so that would be pretty easy to do. That doesn't sound like it's too difficult. All right, let's try another problem here. Here's a more complicated one. And sometimes it's fun to just put these below each other. So the 3 just kind of falls through. 2 and 2 make 4. And the b just comes, falls right through there. Minus, now we're going to do the same thing here. 3, a squared just comes through. And the b1, if it doesn't have an exponent, remember it's a 1 and 2 makes 3. So it's not 0 plus 2, it's 1 plus 2. And that's it. Then later on, we're going to factor these and work them backwards, obviously. So we can factor and then get back to this original problem. So we can multiply them out and we can divide them. So that's pretty much the idea. Let's multiply. I'm going to skip one here. Let's multiply this binomial times a trinomial. Well, it's the same idea. We just kind of forget that this 2 is here. We just kind of cover it with our finger, and we're going to distribute the p to every term. So all these are just going to get a little bit bigger. This will be, I'll put it over here, p5 minus 2p4 plus 3p. Then we're going to distribute the 2 to each term, plus 2p4. So now I'm multiplying everything by the 2, minus 4p3 and plus 6. Now here I could combine like terms, but I'm going to jump the gun a little bit. I see that this is a negative 2 and a positive 2, so those two terms are going to cancel out. And I put this in descending order. I start with the p5, then I go down to the p4. This is a minus 4p cubed. I put that term next, then the p term, and finally the 6. So I end up with 4 terms, which is kind of cool. Originally I had 1, 2, 3, 4, 5, 6, but I want to simplify it as much as I can. I don't want to stop here. I want to stop when I get it as simple as possible. So you can see it's not too hard. Sometimes we can multiply a trinomial times a binomial, times a trinomial. Let's try one. These are kind of not hard problems. They just time consuming. Here actually we have 4 terms and we're going to multiply them by 3 terms. Could we swap these? Could I put the 3 here and then the 4? Yes. It's a commutative, so we can multiply in any order. But since the problem was written this way, we'll just do it this way. So I'm going to distribute this 5x cubed. So this will be a negative 10 x to the 5. And then a 15 x to the 4th. And then finally a 30 x to the 3rd. Okay, now I'm going to do the 3x squared. And I've got a negative 6x to the 4th. So I'm going to just put that under here, save some work. And then I'm going to distribute the 3x squared here. So that gave me 9x cubed. Put it under the next one. Sometimes they don't come out so nice. And then finally 18x squared. Now I'm going to multiply by the x. And I get a negative 2x cubed. Put that under here, negative 2x cubed. And then I'm multiplying by the x. I better remember what I'm multiplying by. 3x squared. And finally 6x. Then finally I'm going to multiply by the negative 4. So I get a negative 8x squared and a negative 12x, and finally a negative 24. This way, your problem, instead of putting it all on one line, which wouldn't even fit on the paper, this way it's kind of a little bit more organized, and it's all in descending order. So I get the negative 10x to the 5th. These two I can just calculate, but notice this is very important, when I add these up, when I multiply, the exponents change, but now the exponents are going to stay the same. This is a common mistake I see, is that students want to make this x to the 8th. You don't want to do that. Only when you multiply. You're adding right now, or subtracting. You got 30 plus 9, take away 2, looks like 37. X cubed. Here you got a 21, take away 8 would be a positive 13. X squared. Here you have a negative 6x and a minus 24. Let's see if I get lucky and get the right answer. A little mess up here. Something about my sign. This should have been a positive. What happened there? I double check it. Minus 6x minus 24. So I made a little mistake right here when I was distributing a negative 4. Yes, a negative times a negative is a positive. So I can see I made a mistake. And those are, the kind of mistakes that are hard to pick up. 29. Okay, but at least we found a mistake and we corrected it. All right, bingo, bingo, bingo. So let's multiply now a binomial times a binomial. Let's start out with a very simple one. And because we do these so often, math guys try to figure out ways to remember them or to do them faster or whatever. So we're going to multiply the first term times the first term. We're going to distribute this x. Pretend like the 5's not even there. So it'd be x times x is x squared. And then we're going to distribute the x to the 8, negative 8x. Now I'm going to multiply everything by the 5. I distributed the x to each term. Now I'm going to distribute the 5 to each term, minus 40. And then I'm going to combine the like terms. Whoops, here. This should be minus 40. But you probably remember from Algebra 1 that they called this...
Trace, you better report that. Trace.
Excuse me?
I don't care, man. I don't care, man.
Let me do something here. All right. So you probably remember from algebra that you called this the FOIL, right? Why? Well, it's the same thing. You're distributing the first to the first. You're distributing the outside, the x to the 8. That was your outer. Then you started multiplying by the 5, inner, and then you multiplied the 5 times the negative 8, the last term times the last term. It's just a technique That makes it easier to remember. First, outside, inside, last. But what you were really doing is just multiplying the x times each term and then the 5 times each term. But it's easier to kind of remember FOIL. I had this one girl that apparently she couldn't spell. Sometimes it would be FLOI, sometimes it would be FIOL. I don't know. But anyhow, that's the way the FOIL works. Let's try a fairly complicated problem. And see if we can FOIL that one. You know, this one looks a little harder. So we're going to go first times first. So 3x squared, x cubed, y. Outside, see, sometimes it's easier to remember, or I call it the rainbow, plus 6 x squared, y squared, y cubed. Are these, and then we're going to go to the inner, the inside, or we're multiplying now by the 2x. That'd be 2x cubed. And finding the last term times the last term. That'd be 4x squared, y squared. So, looks like we ended up with 4 distinct terms. That it seems to match. So that's it. You know, kind of hard to arrange this in any particular order. You just probably have to put it in random order. By the way, what is the degree of this? Do you remember from last time? What's the degree? The degree is the combination of 2 and 3 here. So this would be a degree 4, 5, would it be? Degree 5 polynomial. So this is only a 4, adds up to 4, this adds up to 5, this adds up to 3, and this adds up to 4. So it's a 5th degree polynomial. Okay, so you kind of get the idea. Let's do one more. 2x plus 3y, x minus 4y. And we use this all the time, let me tell you. Yeah, the higher you go in math, the more you use all this stuff. So this will be 2x squared, first times first. Let's put it above it. The outside, this will be a negative 8xy. The inside, okay, when we have two terms, I could write this as 3yx, but by convention, we always write it in alphabetical order, xy. And then the last term times the last term, minus 1y squared, or you could, we'll write it as minus 1y squared. Then we can combine the middle terms. In this case, these are like terms. So 2x squared, that's why we want to put them in alphabetical order, so you can see minus 5xy minus, and I dropped the 1, just write it as y squared. So it looks a little prettier. I made a mistake on that, didn't I? Last term times last term is 12. It'll be still negative, but then it should be minus 12 y squared. Sorry about that. But you know, sometimes these middle terms will combine. Let's do another one like that, just to make sure, because it'll lead to something. Now we're going to get into our special patterns. So you want to kind of make sure. Let's do one more basic one, and then we'll get into the. I'm just making up a problem here. So first times first. Now, one thing that usually when we're multiplying these, usually the first term is going to be a squared term. It's pretty common, you know, that you're going to have an x and an x, and it'll be a, and then the outside term plus 10x. Because I don't know how many times I've seen this, maybe about 10,000 times in my lifetime, that they've written this as 2x instead of 2x squared. You'd be surprised how many mistakes I've seen in my lifetime. Minus 3x minus 15. So then what happens is we got 2x plus 10x minus 3x. This became a binomial somehow. So you want to make sure that the very first term usually is going to have some kind of power. Be careful. You say it wouldn't happen to you, but it does. Plus 7x minus 15. Combining these middle terms. Okay, so what if I had a problem like this? Just an a minus b. Let's make it a plus b to make it a little bit easier. And I wanted to square it. Traditionally, I would write a plus b times a plus b. And I multiply the a times a. See, it comes out with a power. AB. Multiply the middle terms. BA. Want to put it in alphabetical order. AB. And last term times last term. But AB, 1AB, and 1AB are 2AB. So math people look at this and they say to myself, is there a way I could do this faster? What if I could eliminate these two steps? Just not do them. So a way I could do this is I look at this thing and I say, well, this first term was squared. And then it looks like I multiplied a times b and I doubled it. And then I squared the last term. So I squared, double, square. Square, double, square. A square, double, square. Would this always hold up? Well, take my word for it, it will. And if this was a minus sign instead of a plus sign, then this term would be minus. So let's try it on a problem. Let's see if we can do it on a simple problem. Let me get rid of that one. Try something like this. What if I had, I don't know, 2x minus 5 squared? Well, I could do it traditionally, and I will in a minute, but I'm going to use this little shortcut. I'm going to take this first term right here, and I'm going to square it. 2 times 2 is 4. X times x is x squared. Now I'm going to forget about this minus. Well, actually, I'm going to think about this as a 2x times a minus 5. I'm going to think of it that way. Forget about this power right here. I'm going to multiply these together. That'll be negative 10x, and I'm going to double it. Negative 20x. And then I'm going to square the last term. Negative 5 times negative 5 is a positive 25. Square, double square. Let's see if it works. 2x minus 5 times 2x minus 5. I'm going to do this rather rapidly. 4x squared minus 10x minus 10x plus 25. FOIL. 4x squared minus 20x plus 25. Can I do it this way each time? Yeah, if I want to. Or I could use the shortcut. Square, multiply together, double, square. Well, let me tell you, we use this about 1,000,001 times in calculus. And so it comes in very handy to know the square, double square, because sometimes the problems are a little bit more complicated than this one. And if you know the square, double square, instead of doing all this when you're working with radicals and all kinds of stuff, it's a lot faster to know the little shortcut. So you notice it worked with a minus sign and it also worked with a plus sign. The first term came out positive. The last term came out positive because you're squaring a negative number. That's right. All right, let's try another one just to make sure. Yeah, let's see if they got one in the book we could try. Let's try this. 2x plus 3y squared. Yeah, I can multiply 2x plus 3y times 2x plus 3y. This 2 means I have 2 of the parentheses. Now, another mistake I see. Tell me you won't make this mistake. Square that first term, and then you square this term. And sometimes you even forget to multiply the 3, but this should be a 9. No, 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 no. You cannot distribute a power. You cannot distribute a power when there's an addition sign. You have to either write down the problem twice, because there's 2 of these parentheses, or you have to do the shortcut. Square, multiply these together, 2x times 3y, that would be 6xy, double it, 12xy. Double means multiply it by 2, and then square. See how fast that is? Square, multiply together, double, square. Square, double, square. See? Does that look anything like 4x squared? A little bit like this, but this has a middle term, and that's very important. So we want to be careful. All right. Well, what about this one? Well, before we do that, we need to look at one more pattern. Let's put this one on hold, and then I'll come back to it. I forgot to show you another pattern. Here's the other important pattern. This is probably the only one I really knew the best when I was in school. By the way, this is called a perfect square trinomial. Perfect square trinomial, if you want to impress your friends. Okay. The other pattern I noticed was this one. You had a 2x plus 5, but instead of a 2x plus 5 times a 2x plus 5, you had a 2x minus 5. Well, let's do the FOIL on this and see what we get. We get 4x squared, outside minus 10x, inside plus 10x, last term times last term minus 25. Well, what happens when we combine like terms? You see you have a negative 10x, and that's why you want to be careful about your signs. And notice here, so you want to be careful about these signs because you see these cancel out. And a positive 5 times a negative 5 was the negative 25. Is there a way we could do this a lot faster? Well, let's take a look. This was an F, O, I, L. We cross out the O and the I, we get what? Fl, fl. So we could use the fl method to do this. Fl. Kind of a simple way of doing it. First times first, last times last. It's a pattern. If you recognize it, it's going to save you a lot of times. We can do it on a very simple problem. They have to be identical except for the signs. It won't work on x minus 3 and x plus 4. They've got to be the same terms, but different signs. Then we can do first times first, x squared, and last times last, minus 9. See? First and last. So if we recognize this pattern, it's really quick, because we don't have to do all this middle stuff. Let's try one here. What if I had this one? Oh, I make it a fifth. Okay, who wants to do a whole FOIL on this? Because when we do first times first, that's pretty easy. 2 times 2 is 4, 3 times 3 is 9. Don't forget this is going to be a squared term to start off with. But who wants to do the outside? 2, and this would be 15ths, and then the inside. We don't have to because they have opposite signs. Now all we got to do is multiply the last term. Positive times negative is negative, and they always come out with a negative. And 1 times 1 is 1 over 25. m squared. Looked like a really hard problem, wasn't it? 4/9 n squared 1 over 25 m squared. See how easy it can be? You don't want to make it hard. See? So now let's go back to this problem. We could do 5y times everything, 4 times everything, 3x times everything, add up all the terms, and probably make a mistake. But what I see here is this. I see 5y plus 4, 5y plus 4. I see two of them. I see a plus 3x and I see a minus 3x. You see, let's read it like this. Minus 3x. I see a pattern in here. I'm looking at this as a pattern. So I see difference of squares in here. And 5y plus 4 and 5y plus 4, well, that's 5y plus 4 squared minus 3x times 3x is 9x squared. That's what I see here. And then I can do this expansion here. This is a square. Multiply these together, 20, and double. And then square. And then bring this part down. And I've multiplied this whole thing out. It's a square, double square. And I probably would go right from here and not even write this step down. 5y plus 4 squared. And I see difference of square right here. That's why I'm looking for patterns to do these really hard, terrible looking things. Here's another one. I'm going to write this with an x minus 5t instead of an s. This is in your book on page 233, around there. And where this is an x squared minus 25t squared. Okay, so I'm going to multiply these together. I'm going to see what happens here. I got an x squared. I'm going to do that short FOIL. Minus 25t squared. I'm going to make sure I copy this right. Yep. And then I see I have this. Okay, so I did this. Well, this isn't a difference of squares, is it? It's not a difference of squares. So I can't use the difference of squares, but both of these are the same. So I have two of the same parentheses. I have that. I have two of the same parentheses. So now, because this is squared, I can do the square, double squared. Square. Well, what's an x squared squared? We're going to double that power, x to the fourth. Okay, multiply these together and then double them, so that'll be minus 50. See, I'm just doubling that number. X squared, t squared. I don't do anything to the powers. Then I'm going to square this last one. This would be a negative 25 times a negative 25, a positive 625. And you could do that on your calculator. T squared squared, so that'd be t to the fourth. See, I'm just doubling that power. And now I have that whole problem multiplied out without having to multiply this together, doing a FOIL, then getting this answer here, and then FOILing this whole thing out, and then finally combining like terms. I'm looking for patterns, see. So that's what's going to be kind of fun about these problems when you do them. You're looking for patterns. Here's 131 on your assignment. Now, if you don't see it, you can do a FOIL. A FOIL will work. There's nothing wrong with it, but if you see this, you can do a square double square, and it'll be a little faster. X squared. 1/4 doubled. Okay, how do you double 1/4? You multiply it by 2. That'll give you 2/4. And what's 2/4? A half. So this is 1/2 x. And then you're going to square this last term. So that'll be 1/16. See? So that one's a little trickier to do. X squared plus 2/4 or 1/2 x plus 1/16. It's still going to be hard even if you do the FOIL, but this is a little quicker. So think of, off to the side of the paper, 1/4 doubled, that would be multiplied by 2, 2/4, and then reduce that to 1/2. You got it. Now, look at problem number 28. Try as hard as you can. There is no pattern in here. So we can't really do anything special to this problem. So here you do have to multiply the first term times each one, the second term times each one, the last term. There is no shortcut for doing that problem. So once in a while, you're going to run into a situation where there is no shortcut. Here's an interesting one. What do you think the answer to this would be? Well, let's find out. We're going to multiply everything by a cubed, and the a's are going to get bigger, a squared b, and then finally ab squared. Are those like terms? No, they're close, but not the same. Multiply by b, this would be a negative a squared b. Multiply by negative b, this would be a negative ab squared. Multiply by negative b, this would be negative b cubed. Who would have thought that this answer would have been a cubed minus b cubed? Well, this is a special pattern that we recognize. This is what we call a square opposite square. And cube patterns always fall into that thing. When we get into factoring, we discover this pattern, the cube pattern. So maybe in college algebra we do that. Okay, one last one for the road. Let's try this one. Let's say you were in a hurry and you came across this problem. So we want to kind of work this problem out. Let's see what we can do. Now, this looks like it could be a square, double square. The problem is, what do I do with x cubed when I square it? See, that's kind of tricky. You might think it's x to the 9th because you're squaring, but this is x cubed times x cubed, right? Squaring it means multiplying it by itself. So 3 and 3 makes 6. So you have to be kind of careful with your exponents. If it was say there was a 4 in front of here, then let's make that would be obviously 16, 4 squared. But powers don't, you just kind of double them. You don't, think of it as x cubed times x cubed, which would be x, 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 x to the 6. So you have to be kind of careful. Let's leave it with the 4. And then that'd be 8 positive 8x cubed, but then we want to double this, so that would be 16x cubed. square, double, and then square the last term plus 4. So square, double, square. But you have to be kind of careful with the powers because, you know, it may look like you should have put a 9 there and you don't. So I hope this was useful. I mean, you know, because it's kind of fun to do them, a little bit more exciting ones than what we've been doing. On one of the extensions, they have this problem. And this is kind of the problems we deal with in higher math. Here we have weird exponents, but we see this is difference of squares right here, and we add exponents, so that's x to the 2a, and then here this would be minus y to the 2b, short FOIL, FOIL. And now I notice that these are exactly the same except for the signs, so now we can do it again. X to the, and we want to add the exponents, 4a, and we're going to do a short FOIL minus y to the 4b. And then we got our answer C. So even if it's something that looks really complicated, it's not as bad as it looks because we're just doing difference of squares. That's what this pattern is called, difference of squares. Both of these are squared, and difference means that the answer is going to come out. Difference means subtract. So we're going to come out. But remember that you add exponents, just like here. 3 plus 3 is x to the 6. So you want to be careful with your exponents. All right.